This is lesson 7.4. It's about the properties of logarithms. If you recall, a logarithm is the answer to an exponential function, so the properties of logarithms are related to the properties of exponents. By the end of this lesson, you should know the properties of logarithms and you should be able to use them to expand and condense a log. And then you should also know the change of base formula, and that's used for calculating logarithms also. Okay, these are the properties of logarithms. There are only 3 of them. And the first thing you need to know is that the base cannot be equal to 1. So our base number here cannot be equal to 1. Okay, so the property is this. If you have a logarithm with any base and you have 2 things here that are multiplied together, you can expand that multiplication of the two terms into a log of the first one plus log of the second one. So a multiplication here becomes an addition over here. The second property is about division. So if you have a division here, that means you have a subtraction over here when you expand it into 2 separate logs. And the third property says that if you have an exponent here, you can move the exponent to the front and multiply the exponent times the answer to the log base b of m. So we're going to try these properties. They should make more sense in a minute. Okay, so on example A here, we have a subtraction right there. So we're going to condense these 2 logs into one problem. So a subtraction and a division go together. So these 2 different logs can be written as one log, same base of 4, and it will be 32 divided by 2. Subtraction becomes division. So 32 divided by 2 is 16, and log base 4 of 16 we know is 2, because 4 to the second power equals 16, and the answer to a log is the exponent. In example C over here, we have an addition sign. Addition goes to multiplication. So if we take these 2 logs and condense them into one log, it would be 5x times 3x. So it's going to give us log base 4 of 15x squared, taking the 2 logs and condensing them down to one log. In example B here, we have coefficients on the front. So we have the 6 on the front here. We have the 5 on the front here. According to the properties of logarithms, this coefficient on the front is the same as an exponent if we move it back here. So we're going to move these. So we have log base 2 of x to the 6th plus log base 2 of y to the 5th. Then we can take this addition sign here and condense these 2 logs into one. So that would be log base 2 of x to the 6th times y to the 5th, because our addition sign turns into a multiplication sign. In example D, we have again a coefficient. So we're going to move the 2 back here and make it an exponent. So that gives us log base 4 of 6 squared minus log base 4 of 9. So we can take this subtraction here and turn it into a division. So condensing the 2 logs into one, we have 6 squared, which is 36. Subtraction tells us to divide by 9. So we have log base 4 of 4. And we know that log base 4 of 4 is 1, because 4 to the first power equals 4, and the exponent is the answer to the log. Okay, on this slide we're going to do exactly the opposite. We're going to take the single log and we're going to expand it into more than one log. So in example A, we have a division. We know that when you expand a division, it becomes a subtraction. So we have log of 4x minus log of y. And then here we have 4 times x we know we can expand that by making it log of 4, and the multiplication becomes a plus sign, plus log of x minus log of y. In example B, we have our little exponent got lost here. That was a 4. So again, we have division. So we're going to have log base 9 of x to the 4th. The division becomes a subtraction, so then we have log base 9 of 729. Then we have this exponent here that can move to the front and become a coefficient. So we have 4 log base 9 of x minus log base 9 of 729. And that equals 3, because 9 to the 3rd power equals 729. So log base 9 of 729 is just 3. And so there's example B. Example C, again we have division. So since it's division, we can change the division into expanded log. Division becomes subtraction. So we have log base 3 of 250 minus log base 3 of 37. There is no exponent that turns a 3 into a 250, so we can stop there. There also is no log that changes a 3 into a 37, so this is going to be our finished version. Okay, last example. This is a multiplication here. We have 9 times x to the 5th, so we can expand a multiplication by making 2 logs and adding them together. So log base 3 of 9 plus log base 3 of x to the 5th. Log base 3 of 9 is 2, and the 5 that's an exponent here can be brought to the front and turned into a coefficient. So then we have 5 log base 3 of x. That's the end of this first video. The second video will be about change of base formula.